And welcome once again to Strange Planet. Great to have you aboard. About 70 some years ago, nuclear physicist Enrique Fermi reportedly was asked a question about UFOs. And he replied, this may be apocryphal, we're not really sure, we'll find out, but he supposedly said, well, if they exist, where are they? Where are they? And somehow this phrase or this question became known as the Fermi Paradox. Ken Goudsward is here, and he just wrote a book called Fermi's Paradox is BS. That's the family show version. And Ken is a system analyst with expertise in industrial robotics, software engineering, and data design. And he enjoys applying these skills to ancient Hebrew and Sumerian documents, and of course the UFO phenomena. And Ken's home on the web is dimensionfold.com. Dimensionfold.com. Hey Ken, welcome. How are you?
I'm great. Hey, thanks for having me on the show today, Richard. It's really a privilege to be here.
Thank you. So first of all, I was mistaken. I used to think that Fermi's paradox was in response to the Drake equation, this probabilistic argument that, trying to estimate the number of active communicative ET civilizations within the Milky Way galaxy. Except the problem with that is the Drake equation, named after Dr. Frank Drake, that came out about a decade after Fermi reportedly asked the question, where are they? So it wasn't in response to the Drake equation, although one might argue it could have been, in the sense that the Drake equation is saying, well, there are all these, the possibility for all of these ET civilizations, and then Fermi might have then posited, okay, where are they? But so let me back up though. Let me ask you first of all to explain, or kind of set the scene for us. 1950, yeah. Enrique Fermi.
Right. So, just a couple of years earlier, there had been the Roswell incident, of course, which I probably don't need to say much about. I'm sure your listeners are familiar with it. But essentially, what that did more than anything else was it made the flying saucer phenomenon, as it was kind of being called then, the Roswell incident turned that into kind of household name, I guess, if you will. And before that, there were certainly other UFO incidences, but Roswell was what really broke it into the press, and it became a very popular story, and soon everyone was talking about it. And so a lot of speculation and a lot of discussion ensued after that. I'm actually writing another book that's going to be out in about a month probably, called Before Roswell. And so in that book, myself and my co-writer, Barbara DeLong, will discuss the fact that Roswell was not a new thing at all. There had been reports very similar to Roswell afterwards and before, and really for as long as humans have been talking, they've been talking about UFOs. And so that's kind of what that book is about. But in terms of in 1950, it was sort of a fresh idea in terms of just being something that people are discussing. So it's not surprising that Fermi and his colleagues would have discussed it during their lunch break, which apparently is what was happening. What is not necessarily known is whether Fermi said anything about it really, or because the fact that we have we quote him as saying, where is everybody? But it's not a direct quote, and he never verified it. So it's sort of this backwards, like a retcon kind of a thing. And that's the whole thing of the Fermi paradox, particularly. So Fermi may or may not have even said anything about it.
He was
if he
pretty well known
did,
at the time, right? He was a well
yeah,
nuclear physicist. He had never weighed in on the subject before. He never wrote any books or papers about it, right?
right. He it wasn't something that he was interested in really, or certainly academically, he avoided the topic, or at least, it wasn't part of his research. He was a nuclear physicist. He worked in, I believe he worked in the was it the Philadelphia experiment, or some of those early things where they were working on developing the nuclear bomb. So that was kind of his field, and I mean, it's a kind of an all-consuming field. He probably didn't have time to write books about UFOs, even if he wanted to. Um, but so it is interesting that you brought up the Drake equation, and it kind of is this paradox supposedly kind of is in response to the Drake equation. And the reason that we can say that is because it kind of has nothing to do with Fermi. And it didn't start when he said that. Like there was no Fermi paradox until decades later. So at some point after, probably after Fermi's death, somebody had this idea and they wanted to get more credibility out of it. And they thought that it would be good to attach someone famous's name to it. So they kind of retroactively credited it to Fermi, even though he had nothing to do with it. So it's kind of like reverse. What do you call it when you steal somebody's work? Um,
Plagiarism.
Plagiarism. Yeah, it's like reverse plagiarism in a way, where they're attempting to stick a famous person's name onto their idea.
Right, because
We don't know who.
sorry, I was just going to
Yeah,
say
go ahead.
we should give a definition of what is meant by a paradox.
Well, a paradox is kind of this is also an interesting point because even the word paradox is not clearly defined, although it used to be, because it used to be well understood by logicians and philosophers that a paradox is something which apparently is true but seems as if it shouldn't be,
Or the
or
other way around.
is, yeah. Yeah, so now it's also the other way around. So it's like it's something that's true that shouldn't be, or now because just because of common usage, it's also come to mean something that isn't true that is, or that it seems like it should be, or
Right.
but that's not really what it ever meant. So even the word paradox has become a bit of a paradox itself. So it's very very strange. So in the book, I spend a good chapter kind of discussing the idea of paradoxes um, from a logician kind of a point of view, and I examine um, a lot of these what would you call it, fallacies, like logical fallacies.
Right.
And so basically, the idea behind the Fermi paradox is just chock full with a bunch of logical fallacies. However, I like to be fair, so I'm not going to just accuse whoever these guys were who invented this thing. Nobody knows, but I'm not just going to accuse them of using logical fallacies. I'm also pointing out that both sides of the argument, if you want to call it an argument, in terms of, is there life in space or not, uh, both believers and debunkers and skeptics, all both sides are using different fallacies, and sometimes the same fallacies. So,
Right.
so I go through that a little bit in the
Let me
book.
just ask you, if
Um,
I could, Ken. First of all, though,
mhm,
is what is paradoxical about Fermi's statement or question? I should say it's a question.
yeah.
Where are they? What is
Mhm.
paradoxical about that?
Well, really nothing, but ostensibly. So the reason why people think it's a paradox, even though it doesn't really hold water, but the rationale is that you're right. It comes back to the Drake equation. So essentially, the Drake equation says, the universe is so big, and I'm just going to give you the oversimplified version.
Right.
The universe is so big. There's so many stars with so many planets around them, and so that there has to be another version of something like us or something at least as intelligent or whatever. There's just got to be something out there, just statistically speaking.
Right.
Now, I mean, I statistics is possibly one of the evilest things that man has created. Um, but so I'm not even sure how much credence to put in statistics at all. Um, but let's say, okay, maybe there's a valid point to the Drake equation. The Drake equation also has a whole bunch of flaws in terms of mainly because all the variables that it uses, and there's probably 10 or 12 of them, all of them are essentially just pulled out of thin air and they're not evidence based. I mean, some of them have a little bit of evidence, but there's
It's
there's
like
a lot
predicting
of
predicting the climate using models.
well, yes. It would be like predicting the climate using models if you were doing it in 1920 and the only models you had were, oh, look, put a balloon up in the atmosphere.
Okay.
Because that's kind of the level of reliability that we're looking at in that
Okay.
data. Now, having said that, um, astroscience and like the exploration of space has improved leaps and bounds in the last 10 years, and like even in the last 2 or 3 years, we are discovering things at an exponential rate that are very tightly integrated and related to the Drake equation and to the question of whether there may or may not be life in space. And that's kind of the main point of this book, is that we look at um, a lot of these new discoveries in science. For example, we now know of at least 5,000 exoplanets, um, and hundreds of those are within this so-called Goldilocks zone around their sun, which means that it's in a pretty good area in terms of not too hot, not too cold. Um, and on top of that, we are finding traces of water and also oxygen and even biocarbon, like organic molecules everywhere we look in space. So those are kind of three or four other chapters in the book where we look at, well, maybe 10 years ago, it used to be you could ask and have a philosophical debate, is there water in space? Because nobody knew. And so you could guess, or, and a lot of times this is what the Drake equation variables are, is just these like guesses from 10 years ago, or whenever the Drake equation was founded. We've come a long way since then. So I think it's probably time for somebody to come up with a Drake 2.0. And I think that we would be working with a lot better variables and data now. But really, like, yeah, like I was saying, 10 years ago, you could say, is there water in space? Well, who knows? And here's why I think this and why I think that. But now we know definitively that there is water uh, pretty much everywhere we look. There's water on Mars, there's water on the moon, there's water in um, most of the planets within our solar system. Well, probably all of them, but we haven't confirmed a few of them. We have confirmed the presence of air or of like some kind of atmosphere on every single planet and other 9 other moons within our solar system. So the moons of Saturn and Jupiter, a lot of those, um, eh, and our own moon even has an atmosphere, which is not something that we really were talking about 10 years ago. Now, it's not much of an atmosphere, but it's enough to make you have to look at where is it coming from, because the weird thing about the atmosphere on the moon is it can't stick around. Like there's not enough gravity to keep it there, and so it goes drifting off into space. And yet it remains. Like there's something there. So how is that possible? Well, it turns out that air is seeping out from the rock of the moon or inside the moon somewhere. And I'm not saying the moon is hollow, don't get me wrong, but somehow in the moon, these like small traces of oxygen and other elements are coming out that then are light enough to float above the surface, and eventually they disperse. But they're always there because they're always being replaced. Um, and so we're seeing these types of mechanisms, not only in the moon, but also on Mars. We see a very similar situation where Mars actually does have enough atmosphere to make wind. And you can actually see some video from the Mars rover where there's dust clouds being whipped up
Right.
due
Well, the
to wind
European
on
the European
Mars.
Space Agency is heading to Jupiter to survey their moons. And now they may have been dismissed at one time because they're basically like ice balls, but underneath the ice, very, very deep oceans, essentially. So
Well, yeah,
you can even further expand to include planets which we may not have, or moons, not necessarily in what we call the hospitable zone.
right.
So,
Right. Now, so that's very interesting because as it turns out, there was no water on Earth, on the early Earth, because we're too close to the sun. And well, when it was super hot here and the rocks were all still, cooling, it like basically we're living on a lava ball that's still cooling down, right? I mean, that's the point of any planet, is that it used to be a lot hotter and it's all gradually cooling down. That's just how universes work, I guess. Um, but back in the day, like billions of years ago, the the Earth was cooling down and rocks began to form. At that point, water would have been gaseous and just blown off. So all of the water that we have on Earth was not from the Earth's original formation. So where did it come from? Well, during that same time period, um, you have to go out past Venus, past Earth, past Mars. You get to where the asteroid belt is now, and right around that area is where it started to be cold enough for water to form in liquid form. So it seems like just purely by that fact alone, you would think, oh well, maybe there's water in the asteroid zone, or or out past that. Well, yeah, there definitely is, and there's definitely water on Jupiter and Saturn, and these have been verified by like spectrology and other experiments as well. A couple of years ago, I believe it was the Japanese um, space agency sent a probe out to the asteroid belt. Or actually, sorry, I'm getting two things mixed up. They actually intercepted a comet, and they slammed their probe into the comet and videotaped the whole thing. And from like basically their probe split in half, and half of it smashed, and half was the camera. So what they found from that was that this comet is made out of quite a large percentage of frozen water, so ice or snow. It was very loosely packed. Basically, the whole thing was a snowball. Um, since then, a bunch of other work has been done in the last couple of years, in terms of searching for water in the asteroid belt, and um, it's it's insane how much water there is in the asteroid belt. So, like everywhere they look, they're finding water. There's one of the biggest chunks that's in the asteroid belt is a object called Ceres, which is basically a microplanet. Um, and it has a ton of water on it. I'm going to see. I think I have the actual stats right here. Maybe not. Yeah, here it is. So Ceres not only has water, but it has like basically like a geyser, kind of like an Old Faithful type of thing.
Right.
Um, and it's shooting water out from beneath the surface and shooting it into space. It does it at roughly, okay, it's at 3 liters per second. So it's not very much. It's like kind of like pouring out a pop bottle, or well, maybe a little faster than that. Because if you can pour out a pop bottle in a second, um, yeah, that's way too fast. So anyway, a not insubstantial amount of water is just like spewing out of this planet. And that's not the only place. The same type of thing is happening on some of the moons of Jupiter. I can't remember off the top of my head which one it was, but one of them has this massive crater, or not crater, but like a geyser. Um, but the interesting about Ceres is that they have determined that let's see here. It's also got carbon, hydrogen, oxygen, and nitrogen. All of these things are like kind of the basic elements of how organic chemistry works. So interesting. And there's a lot of other clues around those elements, particularly that we're finding again almost everywhere we look.
So all to again reinforce the idea that Drake's equation, which came out like 1961, and I mean, and the estimates were anywhere. I mean, it's almost useless. It's anywhere from 1,000, I think, to 100 million um, planets with civilizations in the Milky Way galaxy. I mean, that's not very useful. That 1,000 to
Yeah,
100 million. But
yeah.
I guess the point here is that even if we're talking about 100 million, that's probably way off. It's an under. We're saying it's underestimating, perhaps.
I have no idea. Maybe there's only one.
Right.
Maybe there aren't any. But like, because it's statistics. Who
Yeah.
knows? I took a statistics class at university, and here's what I learned. If anytime anybody asks me what the probability of that or that is, I say it's 50-50. It either will or it won't. That's all I can figure
Right.
out.
Right.
Um, but yeah, back to the Drake equation thing. I mean, I guess that is the crux of the paradox.
Right.
If there is a paradox at all, uh, which there isn't, but if there was one, it would hinge on these two assumptions.
Right.
So
If there's
one,
100 million planets in the Milky Way that are
mhm,
that have civilizations, where are they?
right. So this is another part of the book, which again, I don't dive too into the field of ufology in this book, um, but it has to be factored in. So here's the paradox, in my opinion. You have I don't know how many scientists are on the Earth right now. At least millions. There's got to be millions of professional scientists. Um, and there's also millions of people who are witnessing strange phenomenon in the skies, uh, and or being contacted, or just have a lot of interesting stories to tell. Some of them sound super weird. Now, being weird isn't is not an excuse to stop using science. So here's the paradox. Why is it that there's all this rich, hugely vast, rich field of data um, that's easily accessible to anyone who cares to look into it? I mean, especially now with the availability of Wikipedia and everything, all the other parts of the internet and Facebook groups that are dedicated to this and stuff like that. Anybody who wants to can easily become an amateur or armchair ufologist. Um, so ology is the science of stuff. So you've got all these scientists who are basically not interested at all in a branch of science. This huge branch of science that's barely been touched, is extremely data rich, um, but is a little bit weird. Now, so what that to me is paradoxical. like, don't you find that if you were a person who wanted to know how the universe worked, you might want to look into this field of data?
Right. In other words, that's the real paradox. It's not
Yeah.
whether they're here, but given the amount of anecdotal evidence, some trace evidence, I mean, there's a huge paper trail. Even the U.S. government and
Hmm.
military are very interested, and yet, from a scientific point, it's absolute crickets. We'll take a quick time
Hmm.
out, and Ken Goudsward stays with us. The Fermi Paradox is BS is the name of the book. Back with more in a moment. What would it feel like to reclaim your health, your vitality, to sleep deeply, to live fully, to address health at the root, at the cellular level, so that your body can detect damage where you have it? Imagine living younger, longer, having the energy to do what you want to do when you want to do it. Discomfort fading away. ASEA Redox Supplement harnesses the power of your body to heal itself, giving you the ability to power your potential. This is one of the most profound health, athletic, and anti-aging discoveries of our lifetime, and we need the world to know about it. If you want to learn more about ASEA, visit strangeplanet.teamasea.com, strangeplanet.teamasea.com, and be sure to text or call my colleague and friend Lynn at 443-254-6024, 443-254-6024 to order or for additional information. ASEA Redox Supplement. It's truly wellness redefined. And we're back with Ken Goudsward. The book is The Fermi Paradox is BS. How do we get a copy?
Well, at the moment, it has not quite been released yet. It actually comes out on February 18th, but I do have a special offer for you guys right now. If you go to my website, dimensionfold.com, you'll see the new releases banner. Yeah, it's got the picture of the book on there. You can click into that, and on there, there is a link to a pre-order for Amazon Kindle version, the ebook, and I think I even have something about some other special offer. You know what? I can't remember exactly what it is, but for sure, you can pre-order the ebook. Um, and if you join the mailing list, you know what? I'll tell you what. If you join the mailing list today, I'll go through and I'll assume that it's listeners of this show, and I will send you guys a link for a free PDF download.
All right, that's great. Thank you. Very
Okay.
generous for my listeners. Keeping them, this is a pre-record, so it'll be maybe a week from
It'll be,
today.
yeah,
What I'll
okay.
do is I'll send you an email as soon as this goes live, and then
Hmm. Sounds
fantastic.
great.
All right. So getting
Um,
back to the real paradox here is that given the amount of evidence, anecdotal, um, trace trace evidence, paper trails, documents, and so forth, where is the scientific curiosity?
yeah, exactly. Um, so now we're starting to, the scientific community almost appears to be acting in a way that is almost more stereotypical with religious dogmatism, in that we've already made up our minds and this is what we believe. So go away. We don't want to talk about it. That's not science.
No, it's the antithesis.
Yeah. Um, Now it's interesting too because and the scientific community eats their young alive if they do cross that line. And not even their young, but even their well-respected members. So I do want to talk about a guy named Richard Hoover. Richard Hoover is the world's leading expert in microbial extraction. So what he does is he'll take a rock, like any old rock, really, and if there is any like fossilized uh, tiny microbial life forms in that rock, he can find it and get it out. Um, Now there's other people on, other people in the field who are, trying to be as good as Richard, but I mean, this guy is like the king. He has this huge track record of all these cool things that he's found. And where it gets really interesting is a lot of the places that he's looking are in meteorites that have fallen to Earth. And so he gets shipped around the world because people are calling him, hey, we've got this meteorite, we want you to examine it. So he'll fly up to Alaska, he'll go over to Africa, wherever he's needed, and he performs his analysis, and he's able to um, extract these fascinating, um, basically tiny fossils. Um, and he's been doing this for quite a long time. I can't remember his first one that did that, but I'm gonna guess maybe 20 years. Um, the guy's a legend in science. Like he actually worked for NASA for 45 years. He holds 11 U.S. patents. He was given NASA's Inventor of the Year award sometime during his tenure there. And now basically all this stuff that he's doing now is kind of like he's retired from NASA, and now this is his new thing.
So he
And
found he found fossils of microbial life inside meteorites that fell from
yeah,
outer space,
yeah,
landed on Earth.
yes, yes,
That should be a
many
splash.
times.
That should be New York
Yeah,
Times big bold headline.
exactly. And actually, to be fair, it has gotten some press, but nobody really knows what to make of it or whatever. I mean, it's in the paper. You can actually, if you Google it, some the New York Times probably did cover it, but it's buried on page 50 or something. Um, but yeah, and so the reason for that is because the scientific community poo-poos it. So even though this guy's got a stellar reputation, um, you you have these pundits saying things like, "Oh, well, he made a mistake," or "He doesn't know what he's doing." Yeah, okay, so look at this. Okay, Mary Leakey, who
Yeah.
discovered Lucy.
Yes.
So she at the time, Mary Leakey was the number one paleontologist. Um, so this is kind of like saying, "Oh, well, I'm interested in paleontology. I teach it at Rutgers or whatever, and so I'm going to come and I'm just going to say that, well, I've never seen the skeleton. I've never been to the site. I didn't look at any of the evidence, but I don't really like what she's saying, so she's wrong and stupid." And that's essentially what the community is doing to Hoover. Like they're literally just calling him names. Um, and it's not that unusual because this has been happening to uh, anybody who is even remotely academic, can't poke their head out of the sand, because everyone else who's got their head stuck in the sand will kick that sand in their faces.
Is that
It's pathetic.
because this is not the whole UFO ET issue is not a scientific problem, it's a political problem. And the
Absolutely.
politics dominate in culture over science. Scientists are dependent on grants. Scientists dependent on tenure. Publishing is, the peer review process and all that. It's all highly politicized. So is that the issue here?
Absolutely, that's the issue. There are many scientists who have lost their jobs, lost their careers, in fact, because they got sick of that, and they did say something. So, in the case of a guy like Hoover, well, he's basically doing like freelance work, so it doesn't really matter if they're calling him names. But if you happen to be maybe in your 30s or 40s, and when you stumble onto something interesting and you happen to work at any kind of university or even a government lab or anything like that, if you find the wrong material and you say the wrong thing, things will go badly for you. Um, I mean, the government does this too, and we've all heard stories like some of the kind of UFO whistleblower guys, like I'm trying to think of a name now. Well, anyway, there's a lot of stories out there, um, where people are even having their lives threatened, or the CIA is busing into their home and stealing their shit. Like, that's not cool.
Well, like
And
the
so,
gentleman out in Nevada that was studying Area 51 had a website dedicated to Area 51, and the military came in en masse. I don't know, there was like something like 30 or 40 individuals that showed up at his door. It was a no-knock warrant. They took away his computer.
right,
They took away everything. No explanation, even to this day.
right, yeah, I saw that on video, right, actually. Yeah, I wish I could think of his name, man. That guy's like, he's kind of a hero of mine, actually. And but my brain is getting old. Um, but yeah, it's really sad that we have to kowtow to the popular opinion, um, in order to maintain any kind of credibility. And why is that? When on the other hand, the people in power can say whatever they want with zero evidence, zero data to back it up, and we're just supposed to go along with it.
You,
There's something seriously wrong with that.
George R. New is the gentleman in Las Vegas. Sorry, I just thought
Okay,
a quick.
I was thinking of someone else, but yeah, there's numerous examples, where you know you you find out something that you're not supposed to know, and then it's like, well, shoot, like, so, and there's a lot of other people who are in that same position, and they probably made maybe a smarter choice, and just didn't say anything. And then
Okay.
there's all the,
So I was just going to say, so given all that, we'll take a time out here in a minute, but we'll
yeah,
get you to address this on the other side. Given all that the suppression um, of evidence, the intimidation, maybe we can refer back then to the Fermi paradox.
absolutely. So
And
I've got a prime example of that.
all right, we'll do that. Ken Goudsward stays with us. The Fermi paradox is BS. What would it feel like to reclaim your health, your vitality, to sleep deeply, to live fully, to address health at the root, at the cellular level, so that your body can detect damage where you have it? Imagine living younger, longer, having the energy to do what you want to do when you want to do it. Discomfort fading away. ASEA Redox Supplement harnesses the power of your body to heal itself, giving you the ability to power your potential. This is one of the most profound health, athletic, and anti-aging discoveries of our lifetime, and we need the world to know about it. If you want to learn more about ASEA, visit strangeplanet.teamasea.com, strangeplanet.teamasea.com, and be sure to text or call my colleague and friend Lynn at 443-254-6024, 443-254-6024 to order or for additional information. ASEA Redox Supplement. It's truly wellness redefined. Ken Goudsward, the Fermi Paradox is BS. And again, just refer us to the website where we can do the pre-order on that.
Yeah, that's dimensionfold.com.
Dimensionfold.com. All right. So relating what we've been talking about, the suppression, the intimidation, the campaign of silence and disinformation, and how that relates back to the Fermi Paradox, which again, title of the book, The Fermi Paradox is BS, attributed to Enrique Fermi, the nuclear physicist in 1950, who posited, well, if these UFOs are so, if these ET civilizations are so plentiful, where are they? So,
Right. So, one really amazing factoid that I had no idea about, until I started digging halfway through writing this book. Um, so this comes down to suppression, and in this case, the culprit is NASA. Now, of course, NASA sort of reports to the government or Senate or something. I don't know how it works, but they're also sort of like self-sufficient. So it's hard to know who's making these calls or why, but check out this story. So in 1976, NASA sent a mission called the Viking mission,
Hmm.
and they orbited Mars and they set down a lander. Now, this is an unmanned mission. Um, we have not sent men to Mars yet, but we will soon. Um, but basically, this lander uh, set down on Mars and did some soil samples and stuff like that, and took a couple small vials of Mars dirt and brought it back to Earth. So we do have samples of Mars soil, and we've been analyzing those for 50 years or however long that is, since 1976. It's a long time. Now, um, they've also, because the NASA guys at the time were sort of cognizant of their own limitations. And so what they did was they analyzed some of the soil, and some of the samples, they just stuck in a deep freeze and have never opened them. So, I mean, good for them. That was very clever, and showed a lot of forethought. So I'd like to see what happens when we open those. But here's what we already know. Now, this is crazy. Like, I could not believe it when I heard this. So right after they got back, or sorry, not even, they didn't even have to get back. This happened while the thing was still on site. So it's there. It's got like a little probe into the dirt, and it's like doing some analysis already, and some various experiments that were designed ahead of time to try out different things with this dirt. Um, and and then they're beaming the results back through radio. So one of the things, there was three, sort of a three-part experiment that was designed by a couple of the top NASA scientific designers. Now, keeping in mind, if you wanted to do an experiment on Mars, you would have to convince NASA that your experiment is a great idea and one that they should spend millions of dollars on. So these guys already passed that test. These are people who worked for NASA. They were like their own guys, and they had designed a couple of tests. Now, these tests involved injecting certain chemicals, or not chemicals, I guess, but well, whatever elements, uh, injecting stuff into the ground on Mars, and then um, depending on what was in the ground to react with it, they would see certain different results that would happen. Now, basically, it's so one of them used like oxygenation, and they were basically, the results would tell them what types of things were in the ground. There was one where they stuck oxygen into the ground. There was one where they stuck carbon dioxide into the ground, and there was one where they stuck water into the ground. Now, all three of these experiments um, had remarkable results, and they were able to capture those results. And I can't get into the technical specifics off the top of my head. I barely understand them myself, but it has to do with the types of reactions that life forms would do due to metabolism. So basically, every time the probe put stuff into the ground, it got metabolized in the same way that it would be if there were living microorganisms in the soil, whether that be fungus or some type of plant life, or like bacteria or something like
Sounds
that.
like you're saying life was discovered on Mars in 1976.
That's exactly what I'm saying. And so when the results were beamed back to NASA, the people who designed the experiments were like shocked and ecstatic, because I mean, they didn't really expect to find life on Mars. Um, but like, and I have their names here. It's Gil Levin and Patricia Stratt. And these are, again, are like high level NASA scientists. Now, they literally said, okay, we found life on Mars, like, and they were ready to go to press with it, but they weren't allowed to. Now, um, both of these two scientists died just in the last 2 years. So uh, one in 2021 and one in 2020. Both of them, on their deathbeds, still said, "Yeah, we found life on Mars." They stuck to it. Um, I mean, they could be wrong, but again, these are smart people. This is kind of the whole thing with the Mary Leakey phenomena again. You can't just say, "Oh, you don't know what you're doing," just because you don't like the results.
Well, the other thing is, okay, maybe there's some question as to whether they were right. Maybe they were misreading the data. What's one of the major tenets of science? It's and an experiment is repeatability. So you try it again
Hmm.
and again.
Exactly, exactly. So in the time since 1976, when they got these, okay, maybe they're inconclusive results. So what does NASA do? They cancel all the Mars programs that were supposed to happen after that, and they don't go back to Mars until now. Now they're talking about doing it again. So finally, um, and it's probably only because they're scared that Elon Musk is going to beat them to the punch, and he will. Like Elon will be on Mars, not himself, but he will have a device on Mars within the next 3 years. He wants to have people on Mars within the next 10 years, and I very strongly believe he will.
And
So
given
he's joining forces with NASA now, and they're working together. So they kind of he's forcing their hands a little bit.
right, as he did with Twitter,
Hmm.
in terms of
Yeah.
transparency. So that'll be very interesting. Ken Goudsward is the author of Fermi's Paradox is BS, and again, dimensionfold.com, and you can order an advanced copy. Check it out. And also, or your very generous offer for people listening to this podcast. Maybe they can use the code word.
Yeah, you know what? I'll just go. I'll just put a link up on that page, and the day that this show airs, that page will have a live PDF download link, and then it's only going to be there for maybe a day or two. So take advantage of it as soon as you hear this show.
A free PDF download.
Yeah.
Very, very kind. Ken, great meeting you. Fascinating discussion. I enjoyed it.
Thank you. You too, Richard.
A new Richard Syrett's Strange Planet drops every Monday, Wednesday, and Friday. Subscribe at strangeplanetpodcast.com.